In this video I'll run you through 4 more examples of long division, and hopefully you continue to develop your skills at this really important technique. Alright, so what we want to do for this first example here is calculate the quotient and remainder when x plus 7 is divided by x plus 5, and it's the classic skill that you require in Year 12. Long division is really good for working on this problem. So we've got x plus 7 here and we're putting x plus 5 into it. Well, another way of looking at that is x plus 5 into x plus 7. So what we're going to do is follow that process that we looked at on Friday with long division, which is we put x into x. Well, that goes once. One lot of x is x, and let's calculate what's left over. One lot of 5 is 5. Maybe we were bracketing that off and subtracting. X take x was 0, and 7 take 5 was 2. So that basically means that x plus 5 goes into x plus 7 once, with 2 remainder, of which we were trying to put this x plus 5 into 2. And there's our answer. Now you can check your work with long division quite easily with your calculator. So we go transformation and fraction, and prop frac is the one that we want. Now what we're going to do is give prop frac the thing we were starting with and the divisor, which is x plus 5, and it'll express that as a fraction for us. So yeah, clearly we got that one right. So now moving on to this problem here. Well, what we can do is check our work once we've done our long division with prop frac as well. There's a couple of good resources on the internet for this. I just did a Google on polynomial long division calculator and looked through a couple of them, and I thought that this was the best one, long division of polynomials calculator from Wolfram. And basically you put the number, the divisor, what you're putting the divisor into, and you just say do it. And the beauty of this one here is it doesn't just give you the answer, it gives you the step-by-step process. If you do a search on YouTube, you'll find a bucket load of videos. Probably the most impressive is Australia's own Eddie Wu, who has a number of examples here of long division of polynomials. And this is him, in action, going through the same problems that I was going through on Friday. Well, not the exact same problems, but the same process with his class over in New South Wales. So Eddie's great to listen to, really clear explanations, and if you want, some backup or something else to look at, then yeah, he's great to look at as well. Alright, but back to my examples. So what I recommend you do at this point is work on this problem. So we're putting x take 1 into x squared plus 4x plus 1. So I recommend you do this problem on a piece of paper, pause the video, and then step my video through and see how you went with your working out. Alright, so here we go, x into x squared. Well, I think that goes x times, because remember, all we're doing really is division. X squared over x, we're putting that into that into that cancels out that, leaving us with x. Now how can I check whether I'm right? Well, what has to happen is when I re-multiply this back again, or when I multiply back again, what has to happen is this needs to be x squared take away x squared. This needs to cancel out. So let's see whether that happens. X times x is x squared. That's good. X times negative 1 is negative x. Bracket, subtract, line. Alright, x squared take x squared is 0. 4x subtract negative x is 4x plus x, which is 5x. Now we're going to bring down the 1, plus 1. Alright, x into 5x goes 5 times. 5 lots of x, 5x. 5 lots of negative 1, negative 5. Line, brackets, subtract. Right, 5x take 5x is nothing. 1 subtract negative 5 is 6. Alright, so that's basically saying that x take 1 goes into that x plus 5 times with remainder 6. But the way we want to write the quotient is x plus 5, and the quotient is 6 and we were trying to put x take 1 into it. Okay, and there is our quotient. Again, let's just check that on the calculator. So we'll go action, transformation, prop frac, and we've got x squared. Don't forget your brackets here, they're important. And we're dividing by x take 1. And we've got x plus 5 plus 6 over x take 1. So we were right. Alright, on to this problem here. So if this x plus 3 is a factor of this cubic here, then we're going to have no remainder. Okay, if we do have remainder, it's not a factor, but let's just check it out and see how we go. Right, so we've got x plus 3, and we're putting that into 4x cubed plus 6x squared, take 5x plus 9. Okay, so again, I recommend you do this on a piece of paper, pause the video, and then come back and check your working against mine to see how we went, or how you went anyway. Alright, x into 4x cubed. Well, I think that goes 4x squared times. How do I know? Let's multiply. 4x squared times x is 4x cubed. 4x squared times 3 is 12. What are we doing? 12x squared. Bracket, subtract. Alright, 4x cubed take away 4x cubed is 0. 6 take away 12x squared is negative 6x squared. Okay, now we bring down the negative 5x. X into negative 6x squared goes what I think is negative 6x times. Let's try and see whether we were right. Negative 6x times x is negative 6x squared. Negative 6x times positive 3 is negative 18x. And we're subtracting. Negative 6x squared take negative 6x squared is the same as negative 6x squared plus 6x squared, which is 0. That's good. Negative 5x subtract negative 18x is the same as negative 5x plus 18, which will give me 13x plus 9, which we've brought down from there. Okay, x into 13x goes 13 times. 13 times x is 13x. 13 times 3 is positive 39. Subtract. Alright, 9 take away, well, I'm assuming that these cancel each other out, but let's just be sure. 13x take 13x is 0. 9 take 39 is 30. So I'm proposing that the quotient is 4x squared take 6x plus 13 plus this 30 remainder over, that should be negative 30. Okay, so again, let's just be careful with these negatives and really talk them through. 9 subtract 39, okay, will be negative 30. So this over here should be an add 30, but instead of putting an add, we'll say subtract negative 30 over x plus 3, which we're trying to put in at the end. Alright, so yeah, you can see here that you know, it's easy to get tripped up over some negatives and positives with this stuff here, and it's also why it's important to then go and check your working out. So we're going to go prop frac and go 4x cubed plus 6x squared take 5x plus 9 divided by x plus 3. And what we got is 4x squared take 6x plus 13 plus 30 over x plus 3. So I was right. So last example here, and it's a bit of a tricky one, so let's see how we go with that. So we're going to put 2x take 3 into, now remember in class that last example that we did, we want to beware of this situation here. Alright, well, when we're dealing with cubics, I like them in the form ax cubed plus bx squared plus cx plus d. Now note that there's no squared term on this problem. But we can actually put one in quite easily, and I'll show you why, or you'll work out why pretty quickly, and if you don't do it, you'll work out why you need to do it. So we're going to put 2x take 3 into 4x cubed plus 0x squared. That's nothing, but so it's going to act as kind of like a placeholder, plus x plus 5. Alright, so let's go ahead and divide. 2x goes into 4x cubed, I think 2x squared times. Let's multiply back. 2 2s are 4, x squared times x is x cubed. 4x cubed, that's a good sign. Now, we're going to do 2 times negative 3 is negative 6x squared. And you'll note that if you didn't have this here, you'd have the x in this position here, and you'd be trying to do x subtract negative 6x squared. It won't clean this up, and therefore your operation or your algorithm will stall at this point. Okay, so whenever you get that happening where you don't get x cubes with x cubes or squareds with squareds, you probably want to go back to the original problem, and I bet you something is happening and there'll be a missing like squared term or x term or something like that. Well, not a missing one, but one with a 0 coefficient. So let's bracket this off and continue the same process. So 4x cubed, take away 4x cubed is nothing. 0x squared subtract negative 6x squared is actually 0x squared plus 6x squared. 6x squared. Bring down the x from there. Alright, 2x into that goes 3x times. Again, how do I check that I'm right? 3x times 2x is 6x squared. 3x times negative 3 is negative 9x. Bracket, bracket, subtract, line. X subtract negative 9x is the same as x plus 9x. That's 10x plus 5. Alright, 2x into 10x goes 5 times. 5 lots of 2x is 10x. 5 lots of negative 3 is negative 15. Bracket, subtract. 10x take 10x is 0. 5 subtract negative 15 is 20. So, to express our quotient, it's 2x squared plus 3x plus 5 plus the remainder, and what we were trying to put into it, 2x take 3. And there is our quotient. So this is basically saying that this goes into this many times. Okay, again, really important to check your working out. So let's go transform, fraction, and prop frac, and put in my cubic, 4x to the 3 plus x plus 5, and we're dividing it by 2x take 3, and we get 2x squared plus 3x plus the 5 plus 20 over 2x take 3. So there's 4 problems for you to practice on, and you know, heaps of problems in your textbook to really further develop your skills at this really vital technique.